Good afternoon, participants. In the second session of the 5 days National XP FDP, I may take the privilege to introduce Professor Dr. Asadur Rahman of NIT Srinagar as a keynote speaker of this session. Dr. Asadur Rahman is presently serving as an assistant professor in the Department of Electrical Engineering, NIT Srinagar, Jammu and Kashmir. Previously, he was associated with NIT Nagaland. He has completed his BTech degree in Electrical and Electronics Engineering. His MTech and PhD degrees are in specialization of Power and Energy Systems. He was the topper of MTech Power and Energy Systems specialization at NIT Silchar. He has also served as Vice Chair of IEEE Student Branch during his PhD studies. He has more than 10 years of teaching and research experience. His research interests include electrical power systems, renewable energy systems, and soft computing techniques. He has recently received a sponsored R&D project of 35.2 lakhs in the field of solar PV thermal technology during March 2022. He was awarded as developer for BRICS Youth Energy Outlook Russia. He has published a book on power system analysis by distributed generation with an international publisher. He has supervised many UG, PG, and PhD projects and has published many international research articles of repute. He is an active member of many professional bodies such as IEEE USA, Institute of Engineers India, IST, Solar Energy Society of India, Soft Computing Research Society India, etc. He is a reviewer of many reputed journals and conferences, including IEEE Transaction on Energy Conversion, IET Generation Transmission and Distribution, IET Renewable Power Generation, and many others. Welcome, sir, to our FDP. Now, I will request Dr. Asadur Rahman to please start his session. Sir. Well, there is some technical issue from the speaker side. Please wait for 2 minutes. Sorry for the inconvenience.
মাঝে মাঝে বলো কিছু না। Everyone is requested to kindly wait. The speaker will join soon. Thank you so much for your patience.
Hello. The organizer kindly respond that am I audible?
Yes, you are audible.
Okay, thank you. Okay, so I think now the screen is also visible over there.
Yes, yes. Yes, sir. It's visible.
Okay, thank you. Sorry for the delay caused. Actually, it happened due to some technical glitch in my computer. So, anyways, we were going to discuss about this optimization in engineering using genetic algorithm. So basically, my discussion will be more focused on the soft computing techniques as well as precisely with the genetic algorithms. We'll see through that and how we can apply this in for the optimization of any engineering problem. So as you know that this is for the part of 5-day national FDP on recent trends in technological advancements for sustainable society in the area of engineering. Okay. I think conducted by the Siliguri Institute of Technology. So this will be the outline of my discussion. Firstly, we'll just have a brief introduction about the computational intelligence, and on that basis, we'll be discussing about the soft computing techniques. Then we'll be coming on to the optimization, that what exactly it is and for what, by what virtue we can solve out any problem. And then we'll go into the details of the genetic algorithm, whole of the individual sections. And finally, we'll find out few of the limitations of genetic algorithm that has been prevailing into the existing literature as well as in the implementations. So this about the computational intelligence, if I give you a broad idea, it can be told that what human intelligence is got through, what we can do is that we can make that into in the forefront, and based on those, we can make some artificial intelligence topologies, which popularly are known as the fuzzy logic and the neural network, whereupon we say that the expert system of the any problem associated with it, the expert your systems can configure out the way it needs to be studied, and that is called the whole study will be comprising for the fuzzy logic. So excluding those things, because I'm not going into that part, just with an ideological structure, we are just dividing it in terms of artificial intelligence as well as the nature inspired computation. Okay, how the computational intelligence can be broadly classified. In nature inspired computation, again, if we go for minute category, we have got several such type of category, but in broad sense, we can say it is for evolutionary computation or the swarm intelligence. So in evolutionary computation, as the initial time, it was started with the genetic algorithm, how the genes or the hereditary process exhibits the better implementation from generation to generation. Those were been incorporated in the computational part, and the genetic algorithm was a popular study of that. So we will be more focused on that because the other studies also have got through with this study of the genetic algorithm in general. Okay. So there are other forms like differential evolution, genetic programming, evolutionary programming. In swarm intelligence, we have got particle swarm optimization and colony optimization, and several such a new mini optimization techniques are flooding into the market. Okay. So now about the soft computing, if I say this whole clusters of the computational intelligence which we have discussed, this all comes under soft computing. So the terminology soft came into this picture. Why? Because we actually don't have to compute every time. And if we don't have the understanding of the background of the problem, still then we can compute out few of the things. So that's why the terminology has not been directly hard computing, rather it is soft computing. In some of the literatures, we'll also find that it's hard computing. Actually, what the researchers mean to say is that when there is a concrete process by which we will be going through phase by phase, like the mathematical processes, that conventional techniques which we have got for different optimizations, those computing structures are actually termed as hard computing. Rest aside, all of the other things we take care of the in the umbrella of soft computing. So actually this goal of the soft computing, it requires to develop an intelligent machines to provide solutions to real world problems. Now, whatever we have written out, it has got a strong meaning is that many a problem we find in the physical world that cannot be exactly modeled out because it doesn't has got a actual physical significance, or it cannot be directly made into in mathematical models or any other form of models also, but still we know that there is a system which needs some of sort of optimization. So what we do is that we take those model or we take the problem, not the model, sorry, the problem, which though cannot be modeled out, we directly exercise with different aspects of soft computing techniques. We try to get some or other way near optimal solutions. Now, when I've come into the terminology of this near optimal, what we can suggest or we can say is that this optimization actually has got 2 point of optimized condition. One is global optimized, one is local optimized. So let us keep those two terms in mind, and then in the coming slides, we will be clearing it out that what we were discussing when there is not a specific model, when we don't know exactly where we need to reach, but still we want the better out of those different conditions. Okay. So for those reasons, we are actually going for the soft computing techniques where we do have got all the darkness in front of us, but in the darkness, it needs to be searched out that some of the possible better options need to be taken out. So the aim is to exploit the tolerance for approximation, uncertainty, imprecision, and particle truth in order to achieve close resemblance with biological processes or human-like decision making. Like we all understand is that human has got the highest level of intelligence among all the living species. So what we need to do is that if we can incorporate those thinking, the human-like thinking ability, human-like thinking ability into a system which works for us to find out the optimal solution, then that is one form of the way how we work on with the soft computing. If not with the human-like decision making, but for the other biological processes by which they evolve out, whichever biological processes by which they have evolved for a better solution, if those attributes can also be taken up into picture, and then we implement it for getting the better or optimal results, we also say that that is coming into the soft computing techniques. So just recalling back, I'll let you know that this artificial intelligence, which I was saying about the fuzzy logic and the neural network, that is mainly depicting the human knowledge or human expertise by which we can go for the different form of solutions. And this nature inspired computation that we are discussing, it is for any biological processes or for any such type of your computational activities which depicts or mimics the biological your processes or the development. Those are also being to be taken up, and it is been taken care by the soft computing techniques. Okay. So now let aside about this soft computing techniques, what is the main purpose of those, or the main goal is that we need to optimize something. Okay. So for optimization in mathematical terms, what we say is that either it may be deterministic or it may be stochastic. Okay. Either it may be like we all have been encountering some or other problems where we need to optimize something. Either we need the maximum of it or we need the minimum of it. Okay. If you are trying to, for an example, if I want to give, if you are trying to minimize something like the cost of any equipment while it is being manufactured, so we will see up that for several such conditions, if the different conditions meet up to give the minimum budget cost for which the equipment can be manufactured into the real market. So in those type of things, we use derivative or gradient type of problems where we try to scale it up in such manner that every time we either go for the top down or we go for the bottom up strategy, okay, for maximization or as well as for the minimization problem. For stochastic type of optimization, which can be classified as such, it's actually derivative free optimization. We'll randomly search around and we will be seeing through that whatever our goal, whatever is the main reach of our problem, we need to target out those by with time to time. Okay. So if I just give a very clear and simple understanding of any optimization, if you are seeing through here for this picture, you can understand that for different value of x, for any function let f, which is a function of vectors x, for any different combination of x, it is giving different function value. And for suppose it is a minimization problem, we obviously need a function for which will be having its for a maximization problem, which will be having for its maximum value of the function. So here, as you can see, it's a very simple and clear diagram which shows that the first tip which is been coming. So this tip is the global optima. That means in the whole of the search space, this is the point where no other point can supersede it, or no other point is much better than this. Because in terms of better, if I say it is a maximization problem, the maximum the value of f, the function, the better the result is. So this is the maximum value of f which it can reach for this search space, and that's why it has been termed as global optima. And the other tips, as you can see, all the tip of the individual your peaks, these are actually higher values, but as compared to some other peaks, it is having something lower. But if suppose we cannot go to a certain local optima and we are stuck to the other local optimas, we may not go up till a point which is called global optima over here. That means we may not go up till the reach to the point of global optima, and we are stuck in between any of the local optimas. So it happens that there is no guarantee about that where we are landing upon, because this is the picture you are seeing and you are knowing that what is your target. But if we are not seeing this and anyone says, let's suppose any of the local optima is been seen through, and several times we search around and we are not passing into the other peaks, we will be understanding that this is our optimal result.